Okay, for example 3 of finding zeros of polynomials, this is a degree 4, so by the time we're done, we should have 4 zeros. So let's start off first by finding the possible zeros. So I'm going to take all the possibilities for the factors of my constant on the top. So I have 24, 12, 8, 6, 4, 3, 2, 1. And on the bottom, that would be all the possibilities for my leading coefficient. And the factors of my coefficient, since it's just 1, would be 1. So when I list out all my possibilities, it would be plus or minus 24, plus or minus 12, plus or minus 8, plus or minus 6, plus or minus 4, plus or minus 3, plus or minus 2, plus or minus 1. Now, I'm going to plug those into my calculator. I would really suggest, if you don't know how to use the table feature on your calculator, to use the video that I'm putting in at the end of this lesson and learn how to use that table feature, because it will make checking these values go so much quicker and so much easier, where you just enter in the function into your y equals, and then you create a t-table, and the calculator will automatically find your corresponding y values for the x values that you plug in. So it'll make it much quicker than trying to plug in each one separately and checking all of them that way. Okay, so the actual zeros, when we go through and we plug in all those different possibilities, what you're going to find is the only the only actual rational zero that we have is 2. So then I'm going to use synthetic division to break this down and factor it. So I have my coefficients of g of x would be 1 for my x to the 4th term. Notice we don't have an x to the 3rd term, so I got to put in a 0 in there to hold that place. So then I have a negative 6 for my x squared term, the negative 8, and 24. I'm going to bring down my 1 to start. I have 2 times 1, which is 2. Add that up, I get 2. 2 times 2 is 4. Add that up, I get a negative 2. 2 times negative 2 is negative 4. When I add that up, I get negative 12. And 2 times negative 12 is negative 24, and I get 0. Because I know that 2 is a 0, we should get a remainder of 0. If not, I did something wrong and I have to go back and check. So now I know, since I have a 0 of 2, I have a factor of x minus 2, and then this tells me the remaining factor when I divide. So I get x to the 3rd plus 2x minus 2x minus 12. Oops, I forgot my squared. Okay, now we have this here, which is a cubic. It's not broken down to a quadratic yet to use the quadratic formula. So what I have to do is just repeat the same process that we just went through, where we use this as a new polynomial and we use the rational zero theorem and break it down a second time. It's a lengthy process, but it's not difficult. It just takes a little bit of time and patience. Okay, so then for this second polynomial that we're trying to break down now, I want to list the possible rational zeros for this one. So I'm going to go through and take plus or minus. If I look at my constant for this polynomial, it's negative 12, so my possibilities are 12, 6, 4, 3, 2, and 1. And my leading coefficient is 1, so that's going to all be over 1. So my possible zeros that I'm going to check on the calculator, plus or minus 12 over 1, 6 over 1, 4 over 1, 3 over 1, 2 over 1, and 1 over 1. Whew, what a mouthful. When I plug those into the calculator, what I'm going to find is that I have 2 as a 0 a second time. So So this tells me that I have a 0 of 2 with a multiplicity of 2. It's a 0 twice. So now I have x minus 2 from the first 0. Then this 0 here gives me another factor of x minus 2. And now I got to find what's left over, what I put in there, by using synthetic division. So I'm going to use synthetic division on this second polynomial. So I'm going to plug in, let's see, my coefficients would be 1, 2, -2, and -12. I'm going to bring down my 1 to start. So 2 times 1 is 2. 2 and 2 is 4. 2 times 4 is 8. When I add those, I get 6. 2 times 6 is 12, and I get a 0, which I should because I know it's a 0. But this helps me break it down again. So now I know this other factor is going to be x squared plus 4x plus 6. And this is not factorable over the rationals, so we can use quadratic formula to finish it up to find the last two. So I'm going to use minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Whoops. A should be 1. Let me put that in there. Okay, when I break this down, I'm going to get minus 4 plus or minus. The inside here is going to give me a negative 8 over 2. And the square root of 8 is 2 square roots of 2. But with that negative, it gives me 2 square roots of 2 with an I, because it's a negative under the square root, over 2. And then when I divide that 2 into everything, 2 goes into -4 and -2. And 2 goes into that 2i with 1. So I have I and then the square root of 2. So here are my 4 zeros. I have 2 twice. So it's 2 with the multiplicity of 2. And then I have -2 plus I square root of 2 and -2 minus I square root of 2. Now those are all the zeros, but only 2 of them are real, which is the 2 2's. So when you look at the graph, if you were going to go ahead and graph this 4th degree polynomial, what you would see is that at 2, because it's a multiplicity of 2, it's going to touch the x-axis and then bounce back off. And those other zeros, the imaginary zeros, aren't going to show up. So you're not going to see that on your graph. You're just going to see that x-intercept of 2 that's going to do a touch and turn because it's a multiplicity of 2.